All right, folks, it's Bass Action, back in action here. In this video, we're going to talk about how to find the asymptotes for a rational function. Remember from the previous video, a rational function is a polynomial divided by another polynomial. Now, what happens, and I'm going to show you some rules here in a moment, but formally what's happening is there's a long division process that's going to happen to find these asymptotes. So in a technical sense, you would actually go through the division process for those two polynomials to find what your asymptote would be. And then your asymptote will be whatever function you're left with. We will ignore the remainder divided by the remainder over the divisor. We'll just ignore this part. So the answer for any asymptote, the horizontal or what we will call obliques, would be this function. Now, it's not necessary to go through this entire division process every time. I am going to show it to you to help you understand where it's coming from, but no, in general, you should not need to do that division process every time. So I'm going to show that. Let's just slide this down and let's jump in. We're going to have several scenarios. Our first scenario would be when we have an actual horizontal asymptote. Now, there are two versions where that horizontal asymptote might happen. The first one is what I'm going to call a bob. Okay, so we're going to have this bob right here. And a bob simply means that it's bigger on the bottom, meaning the degree on the bottom, in this case, the one that I'm giving you right here, the degree on this bottom is a 2, is bigger than the degree on the top, so it's bigger on the bottom. When you have a bob, what's going to happen is the horizontal asymptote will automatically be y equals 0. No work will be necessary at all. If you see you have a bob, you automatically tell me the horizontal asymptote is y equals 0. Now, the reason why this is going to happen is we can go through the division process. So we would go through this long division process to prove it, not to do this on a regular basis. So I would have 2x squared minus 1, and I would start my division process to the 12x plus 1. And what we know from our long division days is that we're taking this 12x, and in our minds, we're dividing it by this 2x squared. But what we remember is that that's when we would stop. We would stop our division when this degree was smaller. So since we're just going to stop here and we'd be done, that's what causes this function is 0. That's what causes this asymptote to be 0. The next scenario that we're going to have is going to be what I'm going to call a SAM. All right, and when I have a SAM, that means same, okay? Meaning the degree on the top is the same as the degree on the bottom. In that case, what we'll do is we will just reduce these leading coefficients. So this asymptote would start off as this 12 over 2, and then we would reduce that and we'd write it as y equals 6. So that would be that asymptote. So you automatically will know you'll have a horizontal if you have a SAM and you just reduce the leading coefficients. Now, why does that one work? Let's jump into that long division. If I start that long division, I would have a 2x squared minus a 1, and I would set this up, and I would have my 12x squared plus my 1. I can spread this out a little bit because I know I've got some gaps. Then I would start by doing this division. I'd take 12x squared, I would divide it by 2x squared, and that would automatically reduce to a 6. When I started then multiplying this out, I'd get my 12x squared minus my 6, and as soon as I went through that subtraction process, or adding the negatives, I would end up with this 7. And since this degree is less than this degree, again, I'm done. So this 6 became the asymptote. I do not ever want you to actually have to go through this process unless you just straight up don't remember the rules. Bobs are y equals 0, SAMs reduce the leading coefficients. The next scenario would be an oblique asymptote. So if it's not a bob or it's not a SAM, there's not a horizontal, but there will be some type of an oblique, okay? Now we're going to have obliques that are lines and obliques that are not lines. We are only going to do obliques that are lines in our class, but I want to show you this one because you certainly might encounter that when you get to your calculus classes. So obliques that are lines are called a bot, okay? They're specifically bots that are more than one. The degree on the top, so it's bigger on the top by exactly 1 degree, it's going to become an equation for a line. You can only get to these by doing the long division, and you can tell that because I gave you a little bit more space for this one. So let's start this long division. I have a 2x squared minus 1. I'm going to set up this long division, and I'm going to have my 12x cubed. We can fill in the placeholders, or I can just even spread this out here. So I would have like a 0x squared plus a 0x plus a 1. It's pretty tight, but we can make it work. And if I start this division, 12x cubed divided by 2x squared, if I go ahead and I reduce that, that gets me to a 6x, okay? Then I start multiplying that out. I'm going to get my 12x cubed minus my 6x. Then I like to add the negative, so I'm going to flip those signs and add. So that's gone. That gets me a 6x. Now, this degree is less than this degree, so I am done. And since I'm done, that means that my asymptote, my oblique asymptote, is going to be this 6x. So I write that as a proper equation. Don't just write 6x. I write y equals 6x. And then when I go to graph it, that's what I would graph. You cannot have a horizontal and an oblique. It's a one or the other, okay? You won't have both. Now, if it's not a line, what it would look like if we went through that long division, what that one would look like is I would have my 2x squared minus 1. I'd set this up, and I'm going to go ahead and have my 12x to the 4th. I'm just going to spread this out and not put my placeholders in there. It doesn't really matter for this purposes. And when I go ahead and I divide that, that's going to give me a 6x squared. Now when I multiply that out, I have my 12x to the 4th, and now I have a minus 6x squared. I'm going to flip those signs and add, just because I like that better. So then I have 6x squared plus the 1, and now I'm going to divide again, because I'm not done this time. So when I divide again, my 6x squared divided by my 2x squared, that's going to give me a plus 3. Multiply that out, 6x squared minus my 3, and now I can see I'm going to be done. And from up above, I know I'm going to ignore my remainder, so I'm just going to stop. It doesn't really matter here. So I can write my final asymptote as y equals 6x squared plus 3. So if you're wondering what this looks like, what you can do is you can take this function, type it into Desmos, and what you will see is that if you type this function in and this one, this graph will approach this asymptote, this parabola that you have drawn in there. It's going to be tucked inside of it. So it's kind of an interesting thing to look at. Now, let's throw this all together and let's just practice a couple now that you've seen the rules. So we're going to combine domain with vertical asymptotes with horizontal asymptotes so that you can kind of see them all side by side. Domain is the same domain discussion that we've been having since the beginning of the year here. So our domain question is going to say we're going to look at the denominators of each of these fractions, and we're going to figure out where it equals 0. On the first one, it's already been factored for us, so we can jump straight to x equals x. Oops, my brain got ahead of myself there. X such that, sorry about that, x such that x is not equal to 0. This is going to be, I'm going to do it mentally, a negative 5/8. And my last one is a positive 7/4. Okay, I want you to be able to do those mentally. Then the next one, what I'm going to do is I'm going to factor this one. So I'm going to say 2x. This one we should be able to factor mentally as well. So I'm going to say 2x. I know I need a 3 and a 1. I can quick check it. That's a positive 2 and a minus 3, and that works. So that domain is going to be x such that x is not equal to 3/2 and a negative 1. My last one is going to be x such that x is not equal to 1/4. Okay, so that's going to take care of all those domains. For vertical asymptotes, we need to do one other thing first. We need to look at our rational functions and determine if anything cancels. So on our first one, I can see that these x's should cancel out. That means that this 0 will become a whole, and you'll learn more about that in the next lesson. That then also means that since that becomes a whole, only the x equals negative 5/8 and the x equals 7/4, only those two become vertical asymptotes. On the next two, nothing's going to cancel, so both of those domain restrictions become vertical asymptotes. And this one also is a vertical asymptote. For the horizontals, we're going to look at whether it's a Bob, Bot, or a Sam. So our first one here, when we look at our function, it is bigger on the bottom. Even after we cancel this, there's a higher degree on the bottom, so this one's going to be a Bob. And when it's a Bob, we saw up above that automatically, no work, it's y equals 0. The next one, I can see that it's a Sam. The degrees are the same, so since that one's a Sam, it starts out as a y equals 6/2. I'm going to reduce that, and I get y equals 3. The last one is a Bot. It's specifically a Bot by 1, which means that I should get a line, an equation for a line. So when I set this one up, I'm going to start my long division, and I have to do long division on this one. So I'm going to start this off, and I'm going to say my 8x squared. I'm going to give myself a gap plus a 2. You can fill in the 0 if you want. 8x squared divided by 4x, that's going to give me a 2x. So now I have an 8x squared minus a 2x. I can flip my signs and add, so those will cancel. So now I'm going to get a 2x plus a 2. 2x over 4x is going to be a 1/2. So I'm going to get a 1/2. And then I don't actually need to continue because I know that my degree will be done. It'll be lower when I finish, so I can stop and just say y equals 2x plus 1/2, and then we would just graph that line. Okay, there's a lot going on here. Get comfortable with those rules, and then make sure that you do turn the page and you practice finding the x and the y intercepts on the next page, because there's some pretty intense algebra that we want to review there.